In this video, we will be reviewing direct variation. In the first example, we need to change from an equation to a graph. And before I start working with this equation, I need to remember that the direct variation equation is always y equals kx. Because I know that y equals kx is my equation, it helps me realize that the 3 in the equation that was given is actually my constant. Now, where this can be helpful is knowing that k will always be y over x. And in this case, since I have a whole number of 3, I will need to turn that whole number into a fraction. So instead of just 3 whole being my k, I need to make my k 3 over 1. Because it's 3 over 1, I know that my y is my 3 and my x is my 1. And in direct variation, we have a term called rise over run. That term comes from the fact that on the y-axis, we rise, and on the x-axis, we run. Okay, those are just description words of what we do on those axes. So now I can graph it by starting at the origin and rising 3 and running 1. From that point, I'll rise 3 and run 1 more. From that point, I'll rise 3 and run 1 more. And I could keep going. The whole point of graphing, though, is to create a straight line. And in order to create a straight line, I only need 2 points. I could have as many as I want, but 2 points is the minimum number of points that I need in order to create a straight line. In the next example, we will be changing from an equation to a table. Now we're going to use the same kind of principle we used last time with y equals kx. That's the direct variation equation. And again, I will use k equals y over x to help me fill in this table. Because the k that they gave me in y equals 5x was a whole number, 5, I need to, once again, put it over 1 so that it becomes a fraction. Now, I realize that my numerator is my y value and my denominator is my x value. So as I come over to the table, I will write 5 as my y and 1 as my x. Now for the remainder of the table, I can just find equivalent pairs. I can multiply by 2, I can multiply by 3, I can multiply by 5 or 10 or 20, any numbers that I want to create equivalent pairs. And you see that I went ahead and filled in the rest of the table with equivalent pairs. And that is how you change from an equation to a table. In this next example, we will change from a table to a graph. Now this is one of the most easy movements or methods that we use, and that is just to take the table and make it an ordered pair. The pairs that are inside here now become x, y ordered pairs. So the first number in the pair is my x value, which is what I go across the x-axis. My second number is the y value, which I go up the y-axis. So the first point, starting from the origin, I go across 1, up 6, and put a point. Now I go back to the origin with my ordered pairs. I go back to the origin, and now I will go across 2 and up 12 to put my second point. Now, that's all that I can fit on this graph because of the numbering and the size of this coordinate plane. So I only need 2 points in order to make a straight line. So my straight line will be from here through the next point and through the origin, creating a straight line that represents direct variation. In the next example, I will convert from a table to an equation. And to do this, I need to remember that k equals y over x. Okay, if I will remember that, then I can take my y value and I can put it in the place of y in that fraction. I can then take my x value and put it in the place of x in the fraction. Now, as I write my equation, all I have to write is y equals, instead of k, I will write 7 halves, and then I'll just bring down my x. So y equals 7 halves x. In this example, we will change from a graph to an equation. And to do this, what we need to do is focus on the actual line that has been graphed, and we need to follow the line all the way up. As we're following the line up, we need to see where is the first place that it crosses the x and the y lines perfectly. And this first place right here is at 1, 1. That would be rise 1, run 1. From my k equals y over x, I will have rise 1, run 1. And 1 over 1 is the same thing as 1 whole. So instead of k in this equation, I will write a 1. So y equals 1x. And in this final example, we will go from a graph to a table. Now, to go from a graph to a table, we need to recognize ordered pairs, because if we remember, a graph is basically, a table is basically a bunch of ordered pairs. So for the first point, I will see that I go across 4 and that I go up 1. The second point, I go across 8, up 2, across 12, up 3, across 16, up 4. And those are all 4 points, which help me fill out all 4 pairs in my table.